Right, so question number 2. So moving on. Right, so X is a p block element in the periodic table. So we have p block element with atomic number less than 20. So these are the elements that we can take where the atomic number is less than 20. Okay, and they say is on burning X in air, a colorless gas X1 is formed. So let's say we are going to burn carbon dioxide, so it will form carbon, so it will form carbon dioxide. So basically this can be carbon, right? And it can be also nitrogen, yes, but nitrogen normally present in the air as N2 molecules. Okay, so then you have oxygen, so it cannot be. And then you have phosphorus. Here, when you burn it, it will form P2O3 or in sometimes P2O5. So those are oxides, which are not typically the gases state. And then you have sulfur. Yeah, sulfur can be sulfur plus oxygen. It will give SO2. Sorry. It will give SO2, and Cl2 it also give oxide, which is not typically a gas. Sometime it will become a liquid. Okay, and it says X1 has a pungent smell. So automatically with our analysis, if you remember with where we discuss about the anions which gives gases with acid, diluted acid, we talk about when there is SO3 2 minus, when you have H plus in the acid, it will form SO2 gas. So SO2 gas, we say it gives a pungent smell. So automatically you can identify X1. This should be SO2. Okay. X1 is readily soluble in water. So this one will be readily soluble in water. And when a solution of barium chloride is added to this solution, a white precipitate X2 is formed and X2 dissolved in diluted HCl to give a weak acid X3. So you know these things because when SO2 is dissolved in water, it will form. So first it is the precipitate X2. So this should be a barium sulfite, because if you remember, I told you when you have sulfate, it will not dissolve in acid. That is another point. But here, this is SO2. When you dissolve this in water, this is what they say, X1 reduced soluble in water. And when it will form the SO3 2 minus, and when you add barium chloride, so SO3 2 minus plus barium 2 plus, it will form this white precipitate barium sulfite. Okay, and then this dissolves in diluted HCl to give a weak acid. So what is the weak acid? It should be H2, SO3. Okay. X1 decolorizes acidified potassium permanganate. So S1 means it is now SO2. So SO2 will be oxidized to SO4 2 minus, while potassium permanganate MnO4 minus will be reduced to Mn2 plus because the solution is acidified. That is what they have mentioned here. And gas X4 is formed when X1 is oxidized. So typically, in the sulfuric acid process, SO2 can be oxidized to SO3 using vanadium pentoxide catalyst or either platinum catalyst. So X4 is this, and it is also used in the manufacture of strong acid. So X5 is sulfuric acid. Okay. Now, think about this question. To identify all these, only one point is enough. What is this? X1 has a pungent smell. because they have already given this is less than 20. So when you think about the element that gives the pungent smell, only sulfur. Okay, basically SO2. So to identify all these compounds, this one point is enough. If you know that anion analysis part, that's it. And identify X and Rho structure in the crystalline state. So this is very important to understand here. So what I want to mention here is now X is sulfur, so you need to write sulfur first. And crystalline, you can draw the S8 molecule like the you know how it forms, right? 1, 2, 3, 4, 5, 6, and there should be another one. The crown structure. So you can draw the crown structure of S8 molecule. Okay. Or you can draw the monoclinic or the rhombic structure. Okay. So you should be familiar with these structures at this point. You can draw the rhombic sulfur structure or either the monoclinic one. Okay, so check these structures. If you forgot those structures, try to remember. You can draw the crown sulfur S8 molecule. So because it is also found in the crystalline state, and the rhombic sulfur or either monoclinic one. So these are naturally present. Okay. And write down the ground state electronic configuration. So you can write down it. Those are very simple thing. And what are the common positive oxidation states? So oxidation states of this is normally present as +2, +4, and +6. So these are the common. Write the chemical formula of common following compounds. So write the chemical formula of the following compounds. So I think it is basically from X1 to X4 that they are asking. And you know now X1 is SO2, X2 is barium sulfide, X3 is the weak acid H2SO3, and X4 is SO3, and X5 is H2SO4. Okay, so this becomes straightforward. Sketch the most stable structures for X1 and X4. Indicate the appropriate bond angles in each case. So X1 is SO2, so you can draw the SO2 molecule showing the lone pair here, and you need to understand the bond angle here is less than 120 because this is a bending. So in fact, if you remember about the previous case, it was around 105 to 106, so 103 to 106, so it could be like this. And X4 is SO3, so it is trigonal planar, so bond angle is around 120. So in fact, it is little lower than 120. If I give the correct bond angles that they expected, so for the bend they are expecting around 118 to 120, and the trigonal planar it is typically 120. You know that. Okay. And write the balanced chemical equation for X1 with acidified potassium permanganate. So this becomes straightforward. So you know X1 is SO2. So you will have 1/2 reaction, SO2 going to SO4 2 minus. So I will use the board very quickly so I can make it easier. So you know these things now. You should know at this point. So one is SO2 going to SO4 2 minus. So there are sulfur is same, 2 oxygen. So I have to put 2H2O here, and then 4H plus. Okay, then I have to balance the charges. No charge in this side. So 4 plus and 2 minus. So I will put 2 electrons. So 4 minus, 4 plus. So charge is neutral at both sides. Okay. And then you know MnO4 minus will be Mn2 plus. So there will be 4 oxygens, so 4H2O and 8H plus and plus 2. So here plus 6 to make it plus 2 plus 7. So I can put 5 electrons. So basically you need to multiply this by 5 and multiply this by 2 to make the overall reaction. Okay, so you need to write the overall reaction as well. So when you write the overall reaction, there will be no electrons included in the overall reaction, and there will be no additional H plus in the both side. H plus should be 1 in the one of the sides. So when you multiply this by 5, this becomes 20 H plus, and when you multiply this by 2, this becomes 16 H plus. So basically there will be only 4 H plus in this side in the overall reaction. And in the same way with water, so you multiply this by 5, so water will be 10 here, and here water will be 8. So you can imagine 10 and 8, there will be 2H2O in this direction, making 4H plus. Okay, so you need to write down the half reactions as well as the balanced overall reaction. Okay, so these three should be written on the paper. Right, so I will share the screen again. Okay, so this is done. So this is another informative question. You can see how much information that you can take about sulfur. Right, so we will move on to the second one. So this is again very straightforward, I would say. So you have given test tube A to E, and basically they are not in order. So this can be these compounds that they have given. A description of the product when it is heated is given below. So before moving on to this description, what you have to do is just heat this. So magnesium nitrate, what is happening when you heat? It will form MgONO2. Then there is oxygen also that can form. Okay, because others are ammonium things. So I have already given some information. You need to know about decomposition of ammonium salts. So there will be here ammonia for ammonium carbonate, CO2 and water, and sodium bicarbonate. You know this when you heat this one, so it will form sodium carbonate. Okay, this will form sodium carbonate, sodium carbonate, and water, and even CO2. Okay, and ammonium nitrate, you know, ammonium nitrite, N2 and water. So this is N2O and water. Okay, at this point you should know. And ammonium sulfate, it will give ammonia and H2SO4. So if you know all these things, what is actually happening here, you can automatically find the solids A to E. So when A is heated, water vapor is given out, colorless and odorless gas turns that lime water creamy. So normally, you know, lime water get creamy because of carbon dioxide. Okay, and it also gives a basic powder, white powder, and it gives water. And what is the compound here? So CO2 should be evolved. So there are two things. The CO2 can be evolved: ammonium carbonate or either sodium bicarbonate. And it gives a colorless gas which turns milky water. So CO2 should be evolved. CO2 is there. And the thing is, there is a white powder. So it should be sodium bicarbonate, because this is ammonia. So this is also gas. All these are gases. So A is sodium bicarbonate because of this white powder case. Okay. Three products which are in gaseous state. So you see all these are gases. Okay. Strong acid and a colorless gas which brown precipitation is less. So you can see the strong acid is H2SO4 ammonium sulfate. D, a white oxide which reacts with water to form a weakly basic solution. So MgO reacting with water form magnesium hydroxide, and a colorless diatomic gas at room temperature, O2, and a red brown gas, NO2. So you can see magnesium nitrate is D. Then last one, water vapor, H2O, and a colorless, tasteless, non-toxic triatomic gas with a linear structure, that is N2O. Okay. So you can easily find the answer for this if you know the products. So this is very important to understand. Know the decomposition of ammonium salts. And the others are just S-block nitrates and S-block bicarbonate. This you should know very simply because that is the first point that you learn in S-block. So this becomes straightforward then. Okay. And write the chemical equation for this reaction in heating. So you know the reaction, then you need to balance, that's all. Okay. Balancing will become very easy because these are very simple reactions. You just need to write down the heating.